Okay, I've been asked a couple times now about questions in the Math Excel homework that involve data points that are supplied and how to use the calculator to find equations of best fit and that sort of thing. So this example comes from Chapter 4, Section 2, number 21. And I don't recall which problem number this is in our Math Excel homework, but I'm fairly certain it does come from the homework 5-6 group. Well, essentially, some marketing manager at a jeans company has recorded some information, and they've essentially found that based on the price of a pair of jeans, whatever price we set to these jeans, we can now see how many jeans have been sold at that price. So essentially, we have the demand value for the price. And the question in this problem comes out to be, does the relation defined by these data points, does it really represent a function? Now, we could try graphing this if we wanted to. We could go to a calculator and make that decision, but I can tell right off the bat that this is not a function, because a function requires each input, and the price value is our input. Each input has exactly one output, and I can see right here the input of 24. It's okay that it occurs twice here, but since the output associated with each of those is a different value, then that right there violates our definition of a function. If I were to input 24 into the input value, the output would be either 57 or 54, and that's a violation of our function definition. So I'm going to go ahead and say no to that. Now moving on, drawing a scatter diagram. There really isn't any multiple choice options here, so we can actually just press continue through that. But I do want to illustrate that we can create this a couple different ways. We could try to plot these data points by hand, where we're treating column P as X values and column D as our Y values. We could just create a plot of those coordinates, or we can go to the calculator. Now, I've done so here already ahead of time, but I do want to show the general process to you. If you press the on button until you get to the home screen and request a new document, then you'll be prompted to create a new page in your document. And to begin with, what we do is we add a lists and spreadsheets page. Now, this list and spreadsheets page will be a spot for you to record the data that you have been provided from the word problem. And I've already done that here in this first page 1-1. What you'll notice is that across the first row, up at the very, very top, I've labeled the columns P and D. To do this technique or to do this process, we do need to label the columns. So I just use the same names from before. And then I recorded the values from the given information as well. So these are the same numbers from the website, and I've just recorded them down the row, or down each row. And I do want to point something out here. I see students with some frequency get to this point where they've entered all the values down one column, and they enter the values down the second, and they move on to the next step, and they get an error message. One thing that I must point out is that when you get to this position and you've entered your last data point, you have to press enter or tab to get out of that cell in order for that value to be accepted by the calculator. If your cursor is active in this cell right here, then the data point isn't recognized, and the computer is going to think that you have a mismatch of data. This column would have 7 items, whereas the computer sees this as a column with only 6 because this last data point hasn't been accepted. So you need to tab or press the enter key out of that cell in order for that value to be accepted. But once you have the data stored in this lists and spreadsheets page, what we do then is we press Control Dock to add a new page, and this time we're going to add a data and statistics page, and we'll actually perform some math, basically statistics, with the data that we've just entered. Now when you do that, the data seems to be scattered all over the place. It's a bit of a mess right now, so we need to provide some organization to that. Since the problem indicates that P is our independent variable and D, demand, is our dependent variable, then I want to place the price variable along our x-axis, and then our demand variable along our y-axis. So if I click this here, I'll select P for the horizontal axis. Then I'll move my cursor, my mouse up here to the left, and choose D for our demand axis. And you can ignore these four options here. Chances are you won't see those on your screen, but if you do, you can just ignore them. And there are our data points, and they do seem to match the data points that were provided here in this sketch. Well, what we would like to do is find an equation that is a function that closely relates to these data points. And to do that, we're going to go into the menu, choose to analyze the graph, and we'll ask the calculator to find a regression of sorts to fit. Now, this data appears to me to be linear. The data points seem to be falling more or less in a straight line. If you think that it looks like a quadratic, a parabolic function, or cubic, a snake-looking function, or quartic, or so on, you could select one of those options to find the equation that fits. But again, in my opinion, I think this is a linear equation, so I'm going to choose option 1, since this linear format looks like the slope-intercept form, and I'm most accustomed to that. You could get the same result here with option 2. It's just going to be reported in a slightly different form. So let's go with number 1. And evidently the calculator has determined that this is the equation that goes through, or that's closest to, all of these data points on the page. Now, it's performed some diagnostics to verify that this is the best line, and most calculators perform the diagnostics the same way, so I'm fairly certain in saying that all calculators will produce the same equation. Now, if you didn't notice, what I did here, let me just cancel out of this, is I went to the menu and I chose the settings options. There are two things that I want to verify here. Number 1, I'd like to display digits and set that to auto. This will show as many digits as that will fit on the screen. That's going to be helpful for our next step. And we're also going to turn on the diagnostics. Now, the diagnostics provide us this value here, which is called our R-squared value. Essentially, the residuals, or the statistical method for us to verify that this line is the best fit, our residuals squared value comes out to be this number. And we need to find the square root of that to answer this question here, to find our R value. So I'm going to jot that down, that R squared is equal to 0.9007. That's usually pretty good, but just to be safe, I'm going to go out a couple extra decimals. 9007, I'll just call this 0379, just to be safe. 0379. Now, we're not interested in the R squared value, but instead we're interested in the R value. So I do need to take the square root of both sides. And in this point, I'm only interested in the 3 decimals, so I'm using my calculator off screen now, and I got a 0.949 as the square root, and when rounded to 3 decimals. But I do need to caution you, since we place the square root symbol on paper, we have to be prepared to answer with either a positive or negative result. And it is important here in Math Excel which one you choose. So what I'll say here is that we will choose positive or negative based on the slope of the line that we perceive. Since this is a downward slope, or a negative slope, I'm going to say that my R value is negative 0.949. So if you need to revisit that technique, please rewind the video and review that again. But we're essentially finding the R value based on using the settings and the diagnostic option in our residual. And if we revisit the calculator and look at the equation one more time, what's being indicated here is that we have a y-intercept on this graph of 88.53. I'm going to round it to 0.53 because this does represent dollar amounts in our function. Actually, no, it doesn't. This is a y-intercept, so our y-coordinate was demand. This is how many jeans would be sold. So based on this diagram, if we backed it up to 0, if our price was 0, evidently we would sell, quote, sell 88.53 jeans. But for every increase in dollar, so our x-axis, every increase in price, every whole number increase in price would be negative 1.33 jeans sold. And that may sound strange at first, but if you think about it, hopefully it starts to make sense that if the price of the jeans go up, then we would expect to sell less or fewer of those jeans. And that's precisely what's happening. For every dollar increase in price, we sell approximately 1.33 fewer jeans. So if I look back at Math Excel as the option, let's see here. So they're saying Part D, interpret the slope. This means that for every dollar the price increases, the demand for jeans goes down by 1.336 jeans. I think that would be the best answer here. We're not saying that for every $1.3 increase. No, that's not appropriate. So A and C are out. And Part D started to throw me for a loop here, but it says for every dollar that the price decreases, then the demand goes down. Well, that's not true. If price decreases, then the demand would go up. More people would try to buy those jeans if the price of those jeans went down. So I like B as the answer here in this case. And so we've already established the equation. We wrote it in function notation in our calculator. The demand based on price. So I like phrasing like B or C, the demand based on the price, and I believe that this is the equation that was the best fit. Yeah, we're not multiplying by P and X. That's not really correct here. We did use the letter X in our equation, but that's only because the calculator is built on f of X and X. So the demand based on price is negative 1.336 times price plus 88.53 jeans. So I like part C as an answer here. And then when we consider the domain of the function, now here we are using set notation, which we haven't spent a lot of time talking about in class, but it is very similar to the interval notation we've dealt with. And the way the set is built is saying that P is our variable for our independent variable. So we will select all P values such that P is greater than 0, or select all P values such that P is a real number. This vertical bar means the phrase such that. When we were using the element notation, we said that P would be an element of some interval of numbers, or P exists between an interval of numbers. This phrase is just a little bit different, and they use a slightly different phrase, or slightly different symbol as well. Well, I don't like option C, and I don't like option D either. We don't want to select all P values that are less than 0. We can't select all real numbers because negative numbers are real numbers as well. So C and D are no good. B looks tempting at first because the price in our scenario were all greater than 20, but essentially the function itself, we could choose any price that we want to set for these jeans as long as that price is greater than 0. We would never set the price to be a negative number. So I'm going to go ahead and select this, option A, and let's see what Math Excel says to that. And there we go. So how many jeans will be demanded if the price is $25 a pair? Well, we've got the function, negative 1.336 times P plus 88. All we have to do is substitute $25 in place of P. And I just used a plain calculator off screen to do that. I took 25 times negative 1.336 and added 88.533. And the answer I got on my calculator was 55.133. 55.133. But of course, we can't have 0.133 of a gene, and the instructions do say to round to the nearest whole number. So I'll just delete that back and go with 55 genes. So evidently at a price of $25, we should be able to sell 55 genes. And it looks like Math Excel was happy with that. So I guess that's it. That's the last question in this set. So hopefully that helps. Our main objective here was to take this data and put it into the calculator and find the equation that best fits. So we did that by using a list and spreadsheets page first, and then creating a data and statistics page second. And we used menu, analyze, regression, and we chose a linear regression this time to find the equation of best fit. Use that technique on other equations as you see fit. And tomorrow in class, I do plan on being there. I'll do my best to answer any questions that you have regarding these assignments. Thanks for watching.